Okay, so today we're going to talk about identifying variables. So our focus question is going to be what variables make up an experiment? So there's three different types of variables that we can have in an experiment. The independent, the dependent, and the control variable. The independent variable is the only known variable in an experiment. It's the only known variable. This is what we are changing. This is what's being changed. When you graph something and there's an independent variable, it's located on the x-axis. The dependent variable would be the unknown variable. It's being measured by the experiment when data is being collected. So this is what you're actually measuring. So if you wanted to know average rainfall in different locations, the thing that you're measuring would be the amount of rainfall. When you graph this, it's located on the y-axis. Control variables are unchanged factors that stay the same throughout an experiment. So they are not influenced by the independent variable and are used to compare results to. So if you wanted to see if a medicine worked, you would test it against someone who was not taking the medicine so that you know if that medicine is actually effective. So let's talk about an example. Let's say that Miss Lambert wants to know which fertilizer will increase the height of her basil plant more. Her independent variable would be fertilizer type. Her dependent variable would be height of the basil plant because this is what we're measuring. And her control would be the plant that receives no fertilizer at all. So the control is always the one that does not receive the treatment. Other independent variables for this experiment might be soil type, age of plant starting, type of basil, amount of sunlight, amount of water the plant is given each day. These all need to remain the same across the experiment so that we know that these are not actually influencing the dependent variable. Our hypotheses and conclusions. So Miss Lambert hypothesized that if fertilizer D is used, then the plants will grow taller because it has more nitrogen and phosphorus in it. So you'll notice that Miss Lambert used an if and then because statement here, just like our hypotheses should be written. A hypothesis, don't forget, is just an educated guess about an event and it is considered testable. So let's say that Miss Lambert ran this experiment and then she got this graph. So on the bottom, you'll notice that there's control, there's fertilizer A, fertilizer B, C, and D. And along the y-axis, we have plant height in inches. And this is 0, 2, 4, 6, 8, 10, 12, 14. You'll notice that they are consistent going up the side by twos. You'll also notice that the control compared to fertilizer D, there is quite a difference in the actual growth of this plant. And as you can see, fertilizer D did have the highest growth or the highest height of plant. So from this, we can then draw conclusions. The plant given fertilizer D grew tallest, therefore we can accept Miss Lambert's hypothesis. Conclusions use our analyzed data to make a statement about the experiment. So just like we did above, we took our data, we analyzed it, and then we made that into a statement. And just as an extra little thing, bar graphs are used for comparing categories. So whenever we're comparing categories of something, we like to use bar graphs. If we were using continuous data, we might use a line graph. There are some other types of graphs that we will talk about later this year, but just remember, as far as this experiment is concerned, for bar graphs, which are used for comparing categories. At a level 0 with a silent hand up if you need help. Complete worksheet in the shared folder named Identifying Variables. Once you are done, you may move on to any extension work that is on the science website.